Hello there. It is my pleasure to be presenting at the IMRC 2022 the work which is titled Development of a Non-Enzymatic Glucose Sensor by Electrochemically Oxidized Copper from a Phenolic Plate. My name is Gilberto Martinez. I currently work as a project engineer at CIDESI, or Center for Engineering and Industrial Development, at the Department of Electronic and Electrical Engineering in the city of Querétaro, Mexico. One of our main interests is the development of microsensors and integrated circuits to tackle different problematics. I would like to start with a brief summary of our work. We have developed a functional non-enzymatic glucose sensor by a technique called electrochemical oxidation using a phenolic copper plate, where we have used silver as a semi-reference electrode and graphite as a counter electrode. Okay, so I'd like to start with a brief introduction of what motivated this work. So as you may all know, diabetes mellitus is a severe health problem worldwide, with the percentage of the population being affected increasing year by year. Now, to properly treat diabetes, glucose levels must be controlled and monitored. So this type of analyte is detected through different biological sensors and different types of technologies such as enzymatic and non-enzymatic. It is important to mention that enzymatic technology is the most widely commercially available, and non-enzymatic is still under development, but it is possible through glucose oxidation with several metal oxides such as copper, nickel, and zinc. I would also like to point out that these types of technologies are not being generated or manufactured in Mexico as of today. Okay, so for the methods we used in this work, we started with a copper phenolic plate, which was etched by laser graving into a 3-electrode system for the sensor strip. And then the working electrode was electrochemically oxidized into copper oxide. We next painted a graphite counter electrode onto the surface of the copper, and we also painted silver onto the surface for a reference or semi-reference electrode. We also used cyclic voltamperometry and chronoamperometric methods for determination of different parameters of the non-enzymatic sensor, such as sensitivity, specificity, and determination of the anodic peaks or oxidation peaks of the system. So now for the results, we have structural characterization by X-ray diffraction. Here we have the original phenolic copper plate, which was oxidized into a mixture of different copper oxide phases. In this case, we have copper 2 oxide and copper 1 oxide. We also performed scanning electron microscopy for determination of the morphology of the working electrode surface. And what we found out is that it is made up of 10 nanometer spherical grains, which are arranged or interlinked into a cavernous structure, which provide an excellent surface area for electrocatalytic oxidation of glucose. We also performed cyclic voltammetry measurements on the sensor. And on the right here, we have different scanning speeds for the working electrode surface. And we see that at 0.6 volts, we have glucose oxidation, and we can observe different oxidation peaks as well that correspond to the oxidation of copper. Now on the left, we have a comparison between a commercial silver chloride silver reference electrode and our semi-reference silver electrode. And we only see a displacement of 0.02 volts, validating this type of semi-reference electrode. Now, the chronoamperometric measurements here show the specificity of the sensor, where we added glucose, and we see a current increase as we added glucose. But we also added different interference in the bloodstream, such as galactose, fructose, lactose, or ascorbic acid, and we do not see an important increase in current, indicating that this non-enzymatic copper oxide type of sensor is appropriate for detection of glucose. On the right, we have cyclic voltamperometric measurements, of the glucose sensing strip, and we see an evident increase in current as we increase the concentration of glucose by 2 millimolar. So in conclusion, we were able to fabricate a non-enzymatic glucose sensing strip based on copper oxide, which is highly specific to glucose and shows a good sensibility to glucose additions. We would like to acknowledge this work to CONACYT for sponsorship of the project for the seed pronaces or LANITEM, and also project number 319037 or EMB. Thank you for your attention.